All right. Not mic inputs. Business cases, healthcare. Here we are. The intent of these ones is to be a little bit of a reprieve from all of the coding that you're doing. I know you just went over a homework, so all those things can be a little bit more taxing than this. But this is just trying to get you an idea of how data science can be applied to different industries. The first one we're going to be looking at is healthcare, right? And we're not going to get you, you're not going to be an expert in the field, unfortunately, but we're going to be able to see how data science pertains to the field and the different tools that they're using and methods. And it's always good to think about the projects that you're going to be doing here in the boot camp and the way that we're going to look at these, right? We're thinking about relevant stakeholders, right? We talked about that when we looked at the helmet example. And, you know, it really depends on who your audience is the way that you're going to approach how you address the problem, who's involved. You know, we're going to be thinking about what kind of value are we generating from our results. And the other thing is, you know, do we have data readily available? Are we working with it in-house, or do we have to go out and try to discover it from somewhere else? Hopefully everyone has these slides. They're a little bit different this time. They're in some HTML format. And if you try to print them, they're all going to be black. So don't try to do anything with that. Just work with this HTML part here. Right. We're going to look at different resources. We're going to be reading some papers today, just casework on it, some different scenarios in terms of healthcare and different problems that they exist. Right. One of them we're going to be looking at is IBM. They were trying to come up with a solution for hospitals that we're seeing, you know, really long lag times and patients, you know, being able to address their problems. Their emergency rooms were so overcrowded that they were having to either, you know, send people away, say we're at capacity, or, you know, people were waiting such a long time that their ailments or anything like that weren't getting addressed. So in that case, it's looking at, you know, how do we forecast what patient volume is going to be like, and you know, how do we give recommendation systems to different people? And we're going to be looking at some other cases on given things. This here is just a resource if anyone wants to go a little bit further than what we're going to be discussing today in terms of, you know, being a data science professional in healthcare. There's a free Coursera course that goes a little bit more into the involvement of it. Anyone here worked in healthcare or desiring to go into the industry? Yeah. You can take it. Take the mic. No? Okay. Yeah. You're here now. Yeah. Right. And don't feel, I'll say this about any of the topics that we're going to be discussing. Don't feel like you're pigeonholing yourself, right? All of these are going to be doing data science methods that you're going to be doing in any one industry, right? So if you decide that, hey, I do want to do a project on healthcare because it's something that interests me, don't avoid it because you think it's not going to help you in the future, because all of the methods that we're going to be going through today that are applicable to healthcare, they're applicable to other industries as well. You know, like I said, we're only going to be focusing on healthcare, marketing, and finance because those are very large sectors. But all of the skills that we use here are going to be transferable to any industry that you find yourself in. So like I said, if you want to go on this, you know, this just gives additional knowledge into healthcare and, you know, how we can aid certain processes through data discovery and analysis, and think about clinical processes, right? Every one of us has probably been to a hospital at some point and maybe noticed a lot of the inefficiencies that happen when going into an office. So as it pertains to healthcare, there are two main data sources, both of which have overwhelming volumes of information being tracked every day, and we really need to find a way of doing certain things like data harmony and integration with all of this information that we have at hand, right? The specific cases that we're going to be looking at is administrative data, which is more like the logistics and processes that a hospital does, right? This would be staffing, right? How many nurses and doctors do we have on duty right now? What are the average wait times at our hospital and things like that? Whereas EHR, which is electronic health records, those are going to be everything that pertain to the patients themselves, right? When you go in and you fill out a form and it's got 1,000 check boxes, each one of those things is going to be something that's logged and tracked, but it more pertains to maybe the diagnostics, the tests that were run on me when I went in. What was my blood pressure, what was my heart rate, different things like that. So one's more logistics and the organization itself. The other one more, what are our patients doing? In terms of the data harmony and integration, this is about, think about different hospitals, right? Every time you go to a different hospital, they all have forms. They might be slightly different. They might ask different questions. The way that they structure it, the inputs that they have on them might be different. But if you're someone who's traveling and you're going to different hospitals in different states, or maybe even in the same state, we want to have a way to kind of transfer that information across it, not have it so disjointed that you're just, repetitiously doing the same process over and over again. And, no one really knows what diagnostics you had done in the past. We're going to list several skills that are important for a data science professional. I know these acronyms aren't listed out here, but EHR, like I said, electronic health records, DSP is data science professional. So there are several skills in terms of machine learning or an analysis that we're going to be doing and looking at through the lens of healthcare. And we're going to evaluate code and documentation for good practices, right? These are things that we've said in the past. You should be commenting on all your information. It should be structured in some kind of logical flow, so that if you weren't present, someone would be able to pick up your work and continue on with the process. Lastly, not listed on here, but towards the end of the class here today, we're going to be looking at exercises of looking up some jobs that are listed for different healthcare organizations, and kind of looking at the job descriptions, what it requires, the base requirements that they'd like you to have as a job. That would be something that is beneficial to you, not only to do in every one of the industries that we're going to be looking at here, but just for yourself to get a general idea of what it's going to require when you go into job placement, and realizing that it's not as daunting as it seems, right? For many of these data analyst roles and entry data science jobs, all of the skills and packages that we use here are the things that they require, right? And you can go through and say, man, I have all of that, right? Rather than thinking, oh, this is so far out of reach, and being overwhelmed with whatever the requirements are for those jobs. So again, in terms of data generation for healthcare, we have administrative data, we have electronic health records, and we're going to have thoughts on how do we link that information, right? When one organization calls it, upper body injury, and one specifies it as a chest injury, how do we know that that was the same patient, right? There are slight nuances that each one of them is going to use when having a certain naming convention. And as data scientists, we need to be able to have reasonable means of connecting that information, or else we're going to be misrepresenting something that's highly sensitive information, right? This is all critical to our life. So we need to do that in a thoughtful way. I know it's wordy, right? We talked about word overload, so I'll just read it to you. You can take a second to just kind of relax and absorb it, right? This is one paper that we take a definition from, and this is in terms of looking at the administrative data, right? It just says healthcare administrative data are generated at every encounter with the healthcare system, whether it's a visit to a physician's office, a diagnostic procedure, an admission to hospital, receipt, prescription at the community pharmacy, the terms healthcare utilization data, administrative healthcare billing records, and so on. These are data collected for administrative or billing purposes, yet can be leveraged to study healthcare delivery benefits, harms, and costs, right? As you go into a waiting room, I mean, we've seen it recently with the world's state of affairs. You might be waiting in a line, right? For definitely for the Med Expresses here, when people were doing COVID tests at the beginning of this, there's a long time to wait. And then, not only that, they had restrictions on, you couldn't sign up beforehand. You had to go to the door and you had to, just let them know you were there. There was different things. They would send you text messages, let you know what number you're in line. And all those are reasons because there are going to be periods of time where offices are overwhelmed. And what do I do as an individual, right? One of the times I was going to get a COVID test, I had to go to 3 different of these ones because you go to one, they're out of tests for the day. You go to another one and it was the same thing, right? You couldn't just, they were taking no walk-ins. You had to schedule beforehand, all kinds of things, right? So it's important that we have an understanding of the information and can utilize data science to make these processes more optimized, right? If anyone wants to actually take a look at the academic paper, it's here and there's a PDF version of it. And you can look at over things in terms of at least the administrative data side. And it's only a few pages there. Most of it's references. So for those of you who are interested, you can take the time to read that one. Continuing with the definitions here, right? Still thinking in terms of administrative data. Healthcare administrative databases are rich sources of information that may be leveraged for research purposes. However, it's important to understand the limitations associated with their use for research. Despite these limitations, the many strengths permit evidence-informed clinical and policy decision-making, right? There are certain reasons why hospitals want to retain their information, right? It's sometimes not comfortable to think about it, but hospitals are businesses, right? And that means that they're in the means of making money. And the way that they do that is they perform tests and operations. So many are not always willing to communicate with one another, right? They see them as their competitors. And this can be really hard when we're, as academics or anything, we're trying to do a type of research. And we want to understand, how can we make predictions about, someone having a certain medical condition without really always having the accurate information at hand because of these limitations. Right. And the reason why we're doing this is we're trying to improve inefficiencies, right? We're going to have bottlenecks, certain things that are limiting the business from doing it. Examples of this kind of data, are when you checked in, how long it took, who administered you, who was helping you in that, what kind of staff were on that day, when did they take breaks. All those things pertain to administrative data and like I said, the logistics of the hospital itself. Any questions on administrative data? Any confusion? It's 5 o'clock. All right. So now we got that side out of the way, but we're going to continue on with these definitions just to get clarity before we get into the cases and start really diving into different examples of data science within it, right? So on the other side, the patient side, the electronic health record is a systematic collection of patient and population electronically stored health information in digital format, right? All of the information that involves what happened when you went in there and the health, like maybe pre-existing health conditions, things like that. These records can be shared across different healthcare settings records are shared through network-connected enterprise-wide information systems or other information network exchanges, right? And this may not always seem like the case. But like I said before, you know, many times you feel like you're repeating yourself when you go into a hospital. Every time you go in, you got to fill out a form again, whether it be an emergency room and you're just trying to get a quick visit. You feel like you're filling out this information. And so as data scientists, what we're trying to do is come up with processes that formalize what's happening here so that things like that don't exist. EHRs may include a range of data, including demographic, medical history, medication allergies, immunization statuses, lab test results, radiology images, vital signs, personal statistics like age, weight, and billing information. Looking at this last sentence here, does anyone see any inherent problems with that? Awesome.
Yeah, it's pretty. A lot of great info there.
Sure. Yeah, and we're thinking about this as patients right now. Those examples are thought through the lens of being a patient, but what about as a data scientist? Yeah, I think you know, James, this is probably what I'm getting at here, and also the one that came after, right? It's not only a lot of information, but each one of these has different types, right? You know, things like age and weight, that's just going to be an integer and a float, right? And the way that we can label that data, yeah, that too, is relatively easy, right? We've seen dictionaries. We have things like keys and values. We could have many keys being your age and weight, and we could have the respective, you know, data types and information filled in there. But we got other things. We got radiology images, right? This is unstructured information that may not always be labeled. So we're mixing that in with things that are more structured, right? We're working with all different types of information, right? You might have a EKG, and you might have a stream of outputs from that, but you also might have visual images, right? I don't know if anyone's ever gotten one. They're a bit strange, right? You're looking at a machine and it's literally got your heart pumping, and they show you the different valves and things that are happening there. So that's not even just an image, that's a recording, and it's not just a stream of data, but it's going to be in image formats, right? So how do we organize this information that has many different forms in maybe a general format that can take in and represent all this different information? Same goes with, you know, a case outside of healthcare. You have a phone, right? When you call someone, that's a voice recording, right? There are many things that I can tell from that. I can hear inflections in it, and I can hear whether you're sad or you're excited, right? Same goes with image recognition and videos, right? If we're on FaceTime, there are different facial expressions that I have, and how do I label that information in a reasonable way? You know, and same goes with the text messages that you send. You know, sometimes it might just be a paragraph, and that's, again, unstructured. It doesn't really have any relationship. So there are ways about, you know, we go through developing means to kind of organize this in a better way. You know, and another thing, not to worry you too much, right? But there are settings added to your phone. Right now we got emojis, we got the reply, right? And all those ways are connecting information, right? What did you actually feel about the text message that somebody sent to you, right? And now I got, you know, a million different emojis that all express different types of emotions that I could feel. Yeah. So we may be working with schema in the sense that it could be a SQL database, but it could be a NoSQL database and be something like MongoDB, which has no schema to it, right? No pre-existing organization on it. And we just got a flow of information, and we have, you know, a JSON to look at that organizes the different information. So, you know, every way that this comes about, there are different ways that we have to organize it. And especially in healthcare, there's just a wealth of different forms that information could take. So not only organizing those as a individual organization, but now we're working across a network of hospitals. And how do we formalize the process so that everybody is able to communicate the same thing, you know, so that we can actually utilize what data science is and get good at that process. Continuing on, you know, again, another paper we could take a look at. And this is, you know, just talking about, again, the potential if we have all of this information and it's organized in a logical manner and we're able to connect it, we can yield a lot more significant results rather than having a bunch of disjointed processes that aren't working together, right? So this definition is just more, like I said, more about electronic health records. Originally designed to facilitate healthcare delivery, are becoming a valuable data source in healthcare research. EHR systems have two components, both of which have various components themselves: points of data entry, management, and analysis. The front end refers to the data are entered, primarily the healthcare workers, specifically, you know, physicians and nurses. The second component being the systems, you know, as electronic data warehouse or backend, where the data is stored in relational databases. EHR data elements can be many types, as we just discussed, which are structured, unstructured free tests, and imaging data, right? Structured being all of those things that we said in terms of diagnostic tests. Unstructured free text is more like, you know, what are the comments that the nurse added in? You have conversations with them and all that's recorded as well. So, you know, it might just be the transcript between the things that you guys discussed. And then we have imaging data, you know, which is another beast in terms of trying to figure out categorization, right? It could be things like we're taking x-rays of lungs and we're trying to see whether this patient, you know, in cases of now COVID or cancer, and how do we correctly identify and label that information as such, right? And one of the main issues with this part right here is thinking about, you know, front end where the data is entered, right? We have nurses who are logging information, and human error is highly possible, right? You know, as we notice, sometimes I'll be up here and coding out a result and I'll miss key and stroke and I'll go through. And it's good to have another eye that, you know, kind of reflects on that and says, no, Luke, it's supposed to be an I, not a 1. And, you know, lets people know that when somebody's entering something wrong, that we have a check on that. But, you know, in the case of the nurses, there's not someone there proofreading everything that they enter, right? So this can be a main thing that they enter in, and it's just natural as a human tendency to sometimes have error. But once that's entered in and it's, you know, in a database, how do we correct for that, right? It becomes a lot harder. And again, that's another job as a data scientist, is analyzing the data frame that we're working with and saying, all right, does this make sense? Does all of these variables line up, right? As you'll see later on, in terms of the machine learning project, when looking at the housing data, I might give you a little foresight. There's a place on there. All of the data says all of the houses has electricity, but there's one that doesn't, right? So what does that mean? You know, what is this place that doesn't have any electricity? Is it actually a house? Should we include it in the data set? It's not always easy to say, and you know, was it properly labeled? We don't know. So, you know, again, just a tidbit here, if you want to read that paper on the power of electronic health records, feel free to. One note about what you guys said in terms of the security aspect, and we'll see moving forward in these papers, is that Usually this information is vetted before someone starts to analyze it, but that can cause its own problems, right? As I try to make people anonymous, I have to get rid of some things, right? Some information that might be useful in analysis by making corrections for that. So then we got a question, should we link these data? Should we put it together in some kind of way that makes it easier for analysis? Or is it more important as a business to keep the information for myself? So here's a short summary that I'd like you to read. Just go over the abstract and start to think about the things that are going on in this paper here. You don't have to find the actual one. Just look over this abstract here. All right, what were these academics trying to do here? Yeah. One side note of this, if anyone, well, everyone, when doing your projects, if you want an idea of how to do a good README, that's it right there. Your README is nothing more than an abstract of what your project is. So if you need a layout or some more grounded way to write it or think about it, this is a good way to do that. yeah, back to this in particular, they were trying to compare the completeness, right, of the two things that we've just been discussing in terms of the data in healthcare records, right? And what they found is in one part, right, it was 94%, compared with it, but the other one, right, they only had around 68%, right? And they called it a reasonable capture of information. But what is reasonable, right? If 30 or 40% of my information, I'm not able to connect it to another spot, that can be significant, right? And this is for a number of reasons, right? Like what I said earlier, people are keying information. We have human error. Not everyone's labeling everything the same. And, with that amount of incompleteness, what kind of results are we able to derive from it? And how strong is our analysis if we are missing a large portion of information? Right, but they say it's needed to have a comprehensive picture of patients' healthcare and health histories, right? Both these things have effects, right? Businesses overcrowding or anything like that. It could have been, a significant event. Maybe there was a sporting event. Everyone got there, got a little rowdy, and there was, higher cases of injury happening that day. What was the weather like? We just saw snow come through really quickly, and all of a sudden we had a significant amount of snow, and there's all kinds of injuries that happen after that, accidents that people get into. So we really need not only a history of what a patient's health is like, but we need the administrative side and sometimes external data as well. Here's just another quick abstract I'd like you to read. And take a few minutes to read that, and then we'll go on break, come back and discuss it. All right. So what's going on in this one? Relatively the same thing.
EHR records, and then they go with hot. About how automation, how big the EHR surveillance system is. But they won't say what their recommendations for are for their conclusion.
Yeah, so we're trying to put together, or they are, should I say, a comprehensive way to look at eye health and do an analysis for that, right? And they're looking at 3 sources, and each one of them by itself really isn't the full picture of it, but they need to do it in combination, right? And this is going to be one of the major skill sets that you have as a data scientist, and you know, it's going to be very valuable to businesses, is being able to look at multiple sources and connect them in some kind of meaningful way, right? As many of you probably saw in your projects, not everything is easily found in one place, and often you're going to have to go multiple places to find all of the information and combine them in certain ways in order to get a whole picture of whatever it is that you're trying to address, right? And so, you know, we saw this in SQL when we were first starting to query information and learning how to join different tables, because not only are things going to be stored in a relational database, right, where you're working with different tables and you have to join them, but like I said, you're usually going to have to go elsewhere and find more information to address the problem that you're working with. Right, so same thing. They're trying to make something comprehensive, saying that it's not there. And even when doing so, running into problems because, you know, the tables don't always easily merge with one another. Different syntaxes mean different things, and you got to make sure that everything is able to be put together in a logical way, and not just logical, but actually is connecting to each other on both sides, right? Like if something's labeled 2 different things, maybe they mean the same thing, but how can I determine that? Important takeaways just from these definitions that we've been going over, right? Healthcare industry is a juggernaut of data generation, right? Frequently we hear in New York sirens going off, and you know, that's every moment here, and usually that's bringing patients in. You know, like I said, we saw an influx in this in the healthcare industry, so we try to address it in different ways by having all of these, you know, emergency clinics, right? These are ones that might diagnose some base cases and then send you off to a larger healthcare organization. But how do we address all of this and help all of the patients without, you know, our systems becoming overwhelmed? Both are rich sources of data, but again, we need to be able to put them together really to address problems and figure out the overall picture of what's happening, right? We got to link them together to get an even more fruitful analysis and integrate them. And it's a huge need for data scientists, right? To be able to find different resources and put them together to be able to do a complete analysis of that. This one, we're going to take the next 20, 30 minutes or so. And we're not just reading an abstract in this, we're going to go through the whole paper. And we're going to come back and answer all of these questions. For those of you online, I think there's probably 12 of you. I'll put you in 3 breakout rooms of 4. And right, 3 rooms. And that should be good to go there. Just meet with them, read through the paper, start to think about these questions and how you would address them. And we'll come back in 20 minutes or so and start to go over the questions from it. And those of you here in person, feel free to start talking through what you guys think the answers are after you've had some time to look over it. Hopefully everyone was able to at least skim it, get some general idea as to what was happening there. Who wants to address this first problem? Any of the teams from the groups? Anyone here?
I think they said that their business problem will.
You're good.
I think they mentioned like right at the beginning, that overcrowding was their biggest problem they're trying to address.
Yeah. In terms of thinking about that problem, right? Overcrowding, we got, inefficiencies in the businesses we have here. Who are the different stakeholders that are involved in this one?
David, I think our group says you probably the hospitals, clinics, staff, institutions, but also the patients.
What was that last part?
Also the patient.
Oh, yes, the patient. Yeah. So we got two, right? Maybe more. Intel. They are, at least from the perspective that this was a business venture for them and trying to maybe a little bit promote their tool, which does end up being a little bit of a flaw of this, right? This was Intel working with this hospital, but it does a little bit seem to be a plug for their TAP, the Trusted Analytics Platform, and that they're trying to, one of the things is trying to scale it, right? How do we scale, methods that we're working with? And this is the way that they were trying to do it with their, cloud computing and different processes there. But in terms of thinking about the relevant stakeholders, right? Different people have different needs. As in an organization, the hospital itself, right, is going to run into that problem of, either their customers or patients looking elsewhere, trying to think about other places to attend, or just not getting the care that they need, right? That's a bad issue. Imagine going to the emergency room and you're just sitting there for an hour, but really you're having a heart attack and no one's able to get to you. So that's a severe case from at least the patient side, but also the business, right? How do we know how many people are coming in and how do we address all their needs? There's different ways we can look at the problem based on the stakeholders we have. What's that? Hearing things. Oh. In what way did the Intel and the French hospital use machine learning in the project? Does anyone know what kind of model they were using? Yeah. So let me see if I'll pull up a definition of at least the REMA side of it. It gives you an idea of it. All it is a time series machine learning method, right? Often used. What's that? Yeah. Often used in stocks and analysis for those, right? Autoregressive, it just means that it's looking based on historical values, right? There's only, at least in this one, only one input for an independent variable, right? We're looking at the historical trends of what's happened, and we're trying to make forecasts based on that, right? You can see this in the airline industry, right? There's a lot of seasonality in terms of traveling, right? People are going out during the summer months and things like that, maybe staying in the winter months. So we're really just trying to look at one variable here and do something like this, right? Where we're seeing what it's done in the past. Trend, you have a question? You're just stretching? Okay. Trend being that it slopes upwards or downwards, right? Some constant pattern of going up or down over time. And then seasonality being a cyclical thing that's repeated over and over again, right? We can see this same kind of, spike pattern happening each year. And the way that we can forecast that in the future is with knowing trend, knowing that it's going up, and looking at the seasonal patterns of it, just extrapolating that, right? I'm just giving you a high level of what this is in terms of, because you're going to get to this later with the time series and way past machine learning. The other part you'll need to know is the exogenous, right? That just means everything else, outside factors that go into play in terms of trying to see what the forecast is for a moving average. So again, they used a Remax, and the way that they evaluated, at least trying to find some of the variables to use, was with AIC. Again, you'll see that when you're going through the code in R, but all that is essentially the lower number is better, and it lets you know which variables to keep in your model. But in terms of presentation, at least, I wouldn't take notes or take after, at least in this graph right here. We have green backgrounds with red X's, right? And that might mean you don't want that, but they're indicating that this is their best model and the variables that they're going to keep with red. And to me, that screams like, throw that away or delete it or stop or something like that. So in terms of your presentations, you might want to look at this and say, there's some wrong things here and learn from that part. What were the factors that made them choose the machine learning model that they did? One of them scale, and that was that tap thing, right? This thing, I forget what it stands for, but they had it on there. Basically, like I said, that's Amazon, or not, that's Intel's platform that they were using to scale it, right? This trusted analytics platform. What else though?
Versatility.
Say that again?
Versatility.
Versatility, yeah, right. The model's transparent and trying to figure out which predictors are going into, the predictions that they're making. Interpretability is a main thing that you're going to hear over and over again in data science, and it's becoming, more and more of a need, right? As we work with unsupervised methods, where they call them black box models. You throw in a bunch of inputs, the computer does some kind of thing, and we don't really know how it comes to its results. So figuring out interpretability is a good thing in knowing which factors actually contributed to the output that occurred, right? And in very simple linear models, thinking about maybe one input of like hours studied, and then your grade being the dependent variable, right? That's just a very naive way to look at it, right? We have one input and one output, and how much does that one affect it, right? And we would look at coefficients and saying, oh, maybe for every hour studied, we get 5% higher in our grade, right? But in this, they're looking at multiple factors. There's a lot of things that they're considering, right? We have, is it a weekend? What was the flu rate? What is the seasonality, holiday, max temp, min temp, all of these different inputs, and trying to figure out how they actually influence number of patients that we're going to have in our room. The other thing, like you said, both James, Johannes, right? We're trying to scale this. We're not just doing this for one hospital, but they have several. And how do we make sure that it works on all of the processes that each one of these has? Yeah, cost as well, right? We want to be able to take it and scale it. Some models work better for that, but some get more inefficient as you try to scale it. So which one can we use, and how is it going to work for us? Oh, hate that. What about the next one? What kind of work needed to do in the preparation, and what do you think the challenges were? We've talked about a lot of the challenges already.
Well, didn't they talk about how they need to make sure that the patient history was on the previous data sets?
Yeah. Right. The big thing we talked about at the beginning of this lecture, and many of you said, was sensitivity is the main thing, right? But that causes all kinds of challenges. You know, it might be important to know the proximity that they live from the hospital, right? You know, and you know, how long it took them, yeah, to actually get to the hospital, right? But if we don't know who the patient is, we don't know their, you know, the location of where they live, but that might be a really big contributing factor. You know, was there an accident on the way to the hospital, and did that cause their conditions to get worse? You know, also the things that they're surrounded by, you know, are they in close proximity to landfills? You know, they're like, that seems, you know, a little bit out there, but there are other things that surround you that contribute with your health, right? And air quality is a big one. And if you have poor air quality, you're more likely to be at risk for certain health conditions. But we don't know this if we don't know who you are, right? We can't figure out all of these things. And so there's definitely a lot that you lose in terms of predictability if you just have to make things anonymous and we don't have a full picture of all of the information that we're working with. Why did they incorporate outside data sets?
Universal outside factors that not
Say that again.
there are any like universal external factors that would influence the admission rate that didn't have anything to do with the patient.
Yeah, right. And one I just said, you know, kind of strange with the landfill aspect, but right, we got maximum temp, min temp, things about seasons and holidays. All of that doesn't really pertain to the patient themselves, but it does have a big influence on your health, right? What if there's a heat wave? People are coming in with heat stroke and different things that contribute to that. Yeah. You know, same thing with flu rates, or you know, those are seasonal trends that happen over time. And you know, events like school starting again, right? All of the kids come in now, everybody's got colds, everybody's interacting again, or you have a large sporting event, right? It's the Super Bowl, and now you got millions of people moving to different places together. You know, we see this as we have these last 2 years, and our inability to be able to control certain things like that, right? Large events that happen, and you know, you got people working in proximity, and not only are they more at risk for or different diseases and healthcare things like that, but you know, what if it's spring break and everybody's out partying and getting rowdy, and you know, there's more likelihood of accidents happening in that kind of way, right? People get into fights. You know, there's a overwhelming number for accidental deaths. You know, people just being reckless, not looking across the street when they're walking through, and now everyone's got AirPods, so we're walking out into the street, not listening to what's happening around us, and these are all outside factors that really don't pertain to the you know, historical things that a patient has, or really what's going on in the hospital, but all of these are significant influences in what might happen and reasons why people attend the hospital. Any lessons anyone learned from this, or anything to gain?
What's the company excited about?
Yeah. What else we got? What's going on here? Oh,
Oh, what?
sorry, I can't read that much. Can you keep it to 5 words? Yeah, right. That's accuracy is a big thing, especially with hospitals, right? And we're going to see this. There's a thing called the confusion matrix. I don't really think it's supposed to make you confused because it actually makes a lot of sense. I don't know why the naming of that was, but what it is basically what are the true positive cases? What are the true negative cases? And then what is our chances that we're messing it up, right? We gave a false positive or we gave a false negative, right? A false positive isn't so bad, right? That's like me going to the hospital. They say I have COVID, but I really don't. And what are they going to have to do? They might give me some antibiotics or some medicine like that. It might give them a little bit of a cost in terms of that, right? Or I might have a couple more diagnostic tests done to really confirm that. I might have a second test run. But a false negative is a lot worse, right? I go to the hospital. They say, "Oh no, it's benign." Okay, cool. My life's good. I don't have cancer, but really I do. That's awful. So accuracy in terms of a hospital is significant, right? If you turn patients away and you say, "Oh no, you're all fine," you're going to face litigations. It's not only just on their side, right? Now they have severe health problems that they didn't know, as an individual. But you now as an organization are liable for certain things, and you're going to face huge penalties based on that. So we have to be careful, right, when we're doing our analysis. Sometimes we're going to be working with things that are that impactful, and we can't just kind of just, oh, it's okay, whatever we throw into the model is fine. We really have to be not just intentful about our actions, but be diligent in the work that we're doing. Anything else anyone wants to add from this? Anything? I guess one last thing that I have to add from it is that they set out to achieve making a better process, right? They said, "Oh, we have inefficiencies happening. We're going to come up with some model and we want to make this process better." But they don't reflect on that, right? They don't go back and say, "All right, here's how well this model performed based on, in comparison with things that we did in the past." And if you decide that at the beginning of your project, that's a claim you want to make, you need to circle back around and try to do that, right? Compare it to things that you did in the past and say, how much did we improve? What did we gain from this? Or else really, we have no way of saying that. And that's something important to keep in mind as you round out your projects, right? These ones, first couple ones are just an analysis of trying to analyze and visualize data. But as you get into later projects in your working career, that's going to be one of the things you have to point out, right? Especially if you become a business owner or anything like that, right? You need to say how much better that those things were in the past, right? Or else you might be repeating yourself. And even as a side note of individuals, we got to be able to reflect on the things we've done in the past to know if we're improving, or else we're just kind of drifting along, never getting more efficient or learning, and just kind of repeating some things needlessly. I know you just got done with that one. We got another one here. Same kind of questions. And it's good to get in this frame of mind, right? Especially when working through your own projects. You know, you're going to have the R1 coming up. And these are ways of which you want to be able to organize your presentations and start thinking about it. You know, what was the problem or question that we're trying to answer, right? Who are the stakeholders? What challenges did we occur when going through our project? What kind of solutions did we come up with? And, you know, what did we learn? So I'm gonna put you back in your rooms, and let's give this one another roll. Sure you have been, yeah. All right, fine. We're gonna keep rolling with this one. And then we'll take a break in a moment. We have another one of these case studies in the other section, but that one's pertaining a little bit different, a little bit shorter. All right. So what about this one? What's our problem? Yeah. Anyone? Oh, did I even bring them back? Probably not. Yeah, they're still in there. We'll take a minute. Yeah.
Facebook just bought 20% because of that earnings. Because what? Our earnings report, like, because they put so much investment upfront for the metaverse. And so their earnings does not meet the expectation. About 20%.
Yeah, please don't remind me. Thank you. This past few months has been atrocious for the stock market anyway. So
So mostly
yeah. Hopefully we got everyone back here. I was still talking when you were in groups. Forgot about letting you out of your cells. So anyone from the groups online there, domain problem, question, need? Yeah. So there's a connectivity issue, right? Duplicate patient care, waste of resources. Yeah. Side note, right? This used to be the case with the police departments as well until 1970s and started having what were known as serial killers. And, since they didn't talk to one another, they didn't have an idea of what was going on in the other states. And this is the same case that we're seeing in this paper, right? Where there's multiple hospitals, organizations that are all helping patients, but they don't have any communication with one another. And so people are getting the same tests done over and over again. And, this caused many problems, as we saw somewhere on here. Just said it again. There's a 57-year-old woman, and, she attended 900 times in 3 years, right? So we got someone, this is an outlier, probably, hopefully not, not everyone's going to the emergency room 300 times in a year. If you are, well, that is what it is. But, right, maybe she's attending different hospitals. I'm sure she had to repeat visit some of them. But in this instance, right, it's just an abuse of resources. I don't think she had to pay for this because if she did, she'd be in a lot of debt. But that, it might be also a problem from the business's side, right? Couple of things. It may seem unethical that they're running the test again, even if they had all of the knowledge. But sometimes they may say that one lacks expertise, right? And those other things that we talked about a moment ago is accuracy. Sometimes you get a diagnostic done and, they say everything's all right, but it's really not. So sometimes it's okay to have the same test run again because you might have a different result. But we can't say unless it's done. So it's good that these departments maybe have some connection with one another, but again, like I said, from a business standpoint, they might view each other as a competitor, and they don't want to talk with one another to begin with. Who are the relevant stakeholders here? We got two of the same from the last one, right? The hospitals, the patients. What's a newer group in this one, right? Social workers, like policymakers, right? These are things that are going to have to be, insurance companies. Yeah, right. Policy. They're the ones that are going to be enforcing change if it happens to these organizations. Because, for instance, we don't want to have these inefficiencies of using resources over and over again. And we want to be able to address concerns from different angles, right? Like I said, one side, they're developing the client facing, the customers. It might come up with a dashboard that shows you the wait times in different places. Google's done a good job of this. Not sure where they're getting at all of the rates from each organization, but if you click on something, whether it be a bar, or a hospital, they usually have, or libraries even, is like, what is the volume of people coming in right now? And that's useful, right? I use it all the time for different things, right? If I'm going to be traveling, or I just want to hang out somewhere, what does it look like? Is it busy? Is it dead? Not in the sense of this hospital one, but what do you think that the challenges were here? Yeah. Right. If they do view each other as competitors, it might be really hard to get them to work together, right? They're going to want to keep all of their information private, but yeah, it's a big business. So why would they want to cooperate, right? Who cares if I'm running a test again? It's making me money. But on the opposite side of that, there are laws that are put in place that say that they can't give you poor quality in terms of the way that they treat you, right? They can't just make you good enough so that you can leave, but then a day later you have to come back. There are certain things that are put in place to try to safeguard a little bit against that. But there's definitely a challenge in the way that they're going to communicate together. Yeah. Tell her to go somewhere else and kick a can down the road. Anything else from this? Right, a lot of these are challenges that we face. But anything else to add to the conversation here? Yeah. Well, it's good because it's gonna, like I said, if you didn't have a formal process to your last project, you might want to look at these questions and start to think about it more in this manner, right? At least in terms of the structure of the way you're going to go about your project, and definitely in the way that you're going to present it, right? Thinking about the problem, like I said, stakeholders, issues that you ran into, which we called earlier limitations. What are the limitations in your data? What are the problems that you ran into when going through it? Solutions that you came about, things that you learned from it. What is your direction moving forward? What do you want to expand on it? What would you have done differently? All kinds of things like that. So now we're going to get into harmony and integration, right? And I think we talked a little bit about, we called it normalization in SQL, and it's kind of the same thing here, right? We're trying to make sure that all of our data is connected, make sure that it has logical references to one another, and works well with itself. So we got some more definitions. In terms of integration, This is really working with outside data and trying to make it work with inside sources that you already have, right? This would say we're addressing a problem. We have a lot of corporate information, but we want to know what's happening in the broader world. So we're going to go out and we're going to look at social media and different resources and try to add what conversations are happening to the information that we're looking at. Harmonization just refers to making sure all of the data that you have within your company is succinct, right? We don't want different naming conventions. We want everything uniform. We want to make sure that everybody in this process, like as we look at hospitals, we want to make sure that everybody's taking notes the same way, and so that we can structure it in a way that's uniform. Again, if you want resources on either one of these, they're linked here. And this just makes sure that you can do processes a lot more efficiently, right? If everybody's taking notes the same way and it's all being logged and tracked the same way, then someone doesn't have to do all of the extra work. Unfortunately, we're data scientists. We're going to have to do the extra work when somebody else isn't. We're going to have to clean it. We're going to have to organize it and connect different parts with the integration as well. Just some more on the interpretation of it. We often word integration in the mindset of incorporating or coercing external data in a common or existing data structures, right? We saw this with the IBM case. They were trying to look for, what's going on with the weather, what's going on with flu season and different things that are happening there, and really making that work with the electronic health records that we already have. In terms of harmony, we often use the harmonization from the mindset of combining several sources of data from our warehouses into a common interpretable data structure, right? This is what we worked with when we were working with SQL and we're talking about relational databases and trying to make sure that we don't have it duplicated, right? We have different keys that reference other tables and we can join them and connect them afterwards, but we're really keeping it into a structured way that makes sure that duplication isn't happening over and over again. Some siblings, nicknames. We got ETL, right? In computing, extracting, transform, load is a general procedure of copying data from one or more sources into a destination system, which represents the data differently or in different contexts than other sources. This is often another process that you're going to be doing as a data scientist, right? Before you get any kind of analysis going, you have to first get the information. You have to extract it. You have to transform it into some meaningful output in terms of what you want to be able to do with it. And then you're going to load it, right? We're going to put it in Jupyter notebooks or wherever else that we're working with it and be able to visualize it. You guys went over data visualization today. How was that? Fine, good, bad, nobody liked it. You can be honest. Yeah. But some of it, when you're first looking at it, it's, what is all this? So awesome. All right. I'm going to take you at your word. And if you've run into any problems, I don't know about them. But often we run into problems, right? It's not always straightforward as to working to get the information into the result that we want it to. So the other part of that is this term called data wrangling, right? Or munging, neither of which really sound that appealing. But it's a process of transforming or mapping the data from one raw data form into another format with the intent of making it more appropriate or valuable for a variety of downstream purposes, such as analytics, right? This is, all you can call this is cleaning, right? I'm sweeping my floor. Oftentimes there's going to be added characters, right? Some of you went through the brutal process of trying to scrape and, found out that not everything is available in the way that you want it to be. And you have to do a lot of cleaning before you can even start to do anything that involves an analysis, right? And maybe 80% of the time was just trying to get it and just trying to make it make sense. And so both these things are processes that you're going to be doing over and over again, especially as you have different projects. You know, we're finding the information, but then we got to come to this part, right? We got to start cleaning it, make sure that it's organized and makes sense. And then we can start transforming it into, you know, other features and load the data and do other operations with it.
So,
Yeah.
Isn't that just essentially like reading a CSV or something like that?
Which one?
Data wrangling?
Wrangling is the process of the cleaning it, right? If you lead it, just loading in the CSV, though, I mean, that comes into the part of loading it, right? But, you know, like I said, in the context of hospital information, you know, you're going to get all kinds of different results, right? You know, some people are also subjective in their responses and they word things differently. And like I said, you know, different hospitals could have different labels for the same thing, right? Chest pain versus upper body pain, right? Both those might mean the same thing, but they could be completely different, right? It could have been more like abdominal and that's still upper body to me. So then how do I make sure that those things are synced? So we're going to be doing all of these processes, right? Data warehousing, and some of these you're not going to have to worry too much about, especially the warehousing part of it, right? These are usually a team of data engineers, rather than the person who's analyzing and doing some kind of analysis. You're going to have engineers that are worried about setting up the schema, organizing the data and inputs that it's going to be able to take. But data warehousing is a process of constructing and using a data warehouse. You know, not very informative there. But it's constructed by integrating data in multiple heterogeneous sources that support analytical reporting, ad hoc queries, decision-making, and involves cleaning, integration, and consolidations, right? Hopefully, I mean, the ideal case would be given, you know, we'd just be handed over a beautiful data set and it's already clean, organized for us. And all we have to do is, you know, do some juggling and make some beautiful graphs from it, but that's usually not the case. So all of these things are going to be processes that we're going to be dealing with as a data scientist. Maybe not so much the data warehousing, but it's good to know what your coworkers are doing and how they have an understanding of that part. The thing that we're going to talk about next is ontologies. Does anyone know what an ontology is? Okay. If you don't, it's right here. Right? What it really has to do with is making sure that there's a uniform way that we can talk about processes, right? Issues that we've been seeing in these cases as communication is hard, right? People say different things for the same thing. And we need to have some kind of uniform code that relates to all of the injuries that a patient might have or illnesses, but also shows the connection, right? If you look at a dictionary, it just gives you the key of what a word is and a definition, letting you know what it means, but it doesn't really talk about its relationship in a sentence or how it connects to other things. So an ontology not only gives you an understanding what it is, right, but shows the connection. If I have a burn on my arm or I have one on my leg, they're different places of the body, so they might have, you know, different processes and things that the doctors have to do to address it, but they're both a burn, right? And so how can I show the relationship between those two as well, right? Translation, an agreed set upon terms, fixed definition for each, like a dictionary, but define rules and relationships, right? It goes beyond one. It provides consistency and dependent only on the ontology, not the entity using it, right? I can go on there and I can see what these terms mean, what their definition is. I can see how they connect to different things, right? It's not a slang. It just is what it is. And we can look at this one, right? And let's see. It'll be fun. Snake bite venom. Right. And we have all kinds of codes in here that relate to different types of injuries that are happening. Right. We could have a fracture to the head or neck or femur, or we could have a fracture of a lower femur, other things. And so the beginning part is all the same, right? S72, but has a decimal afterwards to signify it's something else, but still in the related field. And we're starting to, as we get more involved with data science, having to come up with codes like this that mean uniform things through different industries, so that we're aware as to the way that we can connect all of the dots and actually perform some useful analysis in it. Just a reading here from your good old friends at the Outback, not the restaurant. But this one here is just, again, talking about what I just mentioned in terms of big data and ontology, making sure that we're able to speak a uniform language and not all be in disjointed parts. But feel free to read that one on your own. We don't need to spend time in our groups working on that one. These, we've already talked about them, but it's good to reiterate them, right? These are good practices. Our code is well commented, along with any extra documentation we need to provide, and would be interpretable by another, right? If you passed away today and had to pass on your legacy of the code that you did, would someone be able to pick it up, or would they just be lost and everything you did was forgotten? For each data set, we've created a thoughtful data dictionary. As individuals, we tend to label things that make sense to us, but it probably doesn't make sense to someone else. And I don't know about you, but when I first started coding, my variables were almost like a sentence, because I wanted to be very specific about everything, and didn't really know how to abbreviate it in some kind of way that would have made sense to another person. So we have to be careful with that, right? For mapping, this is just about primary keys and foreign keys, right? Are we connecting things in a logical way and making sure that they relate to one another? Have you documented your choices, algorithms, functions, and discuss the interpretability and ideally reproducible, right? We want these things, we just talked about it, to be something that can be implemented at scale, and it needs to be able to be flexible and have the ability to do that. And if not, it's a little bit harder for others to work with it. Oh. So this is just back to the check yourself list, right? For each source of data, we completed a thorough audit and integrity and applicability, right? We also have these things. I don't know if any of you have worked in industries with QA teams, quality assurance, right? We're still seeing this be expanded in terms of data science as well. We have a QA engineer, someone who not only checks if someone's code is accurate, but make sure that it's robust and can handle all of the edge cases that a company may deal with. They have domain expertise and understand what inputs are necessary for the business and how to derive value from that. Do you understand the context of where the data was collected, right? We saw at the very beginning when we were working with SQL that some of those movies were labeled black and white that weren't black and white, right? And we could do a check for that and make sure that that actually stands up with what we're looking at. And we have to be aware of, the resources that were used to collect the information and what mistakes might happen within that. Subjective choices while wrangling, transforming, and how it'll affect our analysis. We should always be open about the assumptions that we made when working with our data, because we do have to make choices like that sometimes. We have to decide on the naming convention of our things, and we have to make sure that it makes sense to other people. How do we address bad data, approach bias in our analysis, right? Sometimes we do have to make that decision of getting rid of information, but how are we deciding that? Are we just arbitrarily saying, all right, we can throw out certain things and not others? Or we have a process with that? And again, these other things, right? Motivation behind our choices and the needs of the business. Are we acting in our own interest, or are we working for the organization and looking it through that lens? We just continue to talk about integration and harmony, but the reason why it's good is because it makes it easier on ourselves, right? If your room is clean, it's easier to find out where keys are. But if it's not, then we don't know to check whether it's in the fridge or anywhere else, or any of our coat jackets and things like that. This paper's a little more involved, so we'll come back to it. A little bit longer than the others. We've been through this process before. So let's get more to the end so that we can actually look at this job posting skill sets part, and that's going to be more beneficial perhaps, because it's going to be something that you're going to do at the end of this cohort when you're actually looking for them yourself. Right? These are important skill sets, especially when thinking about you're going into an interview, right? Having SQL, knowing that every one of the job interviews you have, you're going to have a question on SQL. So at the end of this boot camp, right, we're going to have extra material on that. You're going to have to revisit it and think about the processes. But again, we just went over dplyr, right? And that structure is the same, right? In terms of selecting and filtering and mutating, and all of that should kind of just be a reminder of what SQL looked like and not too far off, right? So hopefully that's helped you reinforce it, right? We got Python and R. You have to be familiar with either of these. I would say that we're moving to the space where we're getting more questions on Python than R, unless you're going into a role of like a statistician. But you may still have to be prepared to know the syntax of it, right? In case you get a curveball, somebody throws it at you and says, all right, no, I want this coded out in R. But both are useful, right? Like Luke was talking about today, R starts everything in vectors. You move up from there and everything's relatively straightforward in that, right? The operations that we've seen, in terms of applying, not applying the skill set, but the function applying, right, is very easy to do it on a whole vector of information without needing to iterate through it or having loops and things like that. So it does have its power and usefulness. Then we talked about harmonization and integration, being able to work with multiple data sets and make sure that all of the information is cohesive. And just the good coding practices at the end, right? Being able to demonstrate the clarity in your work and have someone able to be able to look at it and understand it well. Vocabulary, right? Don't shy away from learning new ontologies. We're learning a new field here. So there's going to be technical terms that are used over and over again. And you want to be able to mimic that in some kind of way, right? It's always best. And you might see, like as a child, that's how they relate with other kids, is they start reflecting the language that other, people they consider their friends. And we do that, subconsciously. We'll go into a group, we'll start to hear common phrases and things like that, and we'll use them over and over again, right? One that I hear in meetings all the time is, oh, I'm going to echo that. And it's like, as soon as one person says it, everybody's saying it, and everybody's just echoing. And, the other one is like, I'm going to piggyback off that. And everybody's piggybacking. We're all in everybody's back. I'm wondering who the guy on the bottom is, because he's probably got some strong legs. Right? But you want to be, as an adult and a data science professional, you want to be conscious about that now, right? Understand what these terms are and why people are using them, what they relate to. The reason why we do that is because we can reference things a lot quicker, right? We can say a whole lot with one word if it has a solid definition and a good meaning. So don't just randomly start blurting them out and thinking that it's useful for you. You got to actually know what it means, right? My friend's a software engineer, and he said he went back to his college to hire people onto the company. And there was a kid that just came up to him and said, "Big data," right? And he's like, "What?" He's like, "I was told by my friends if I said it to get me hired," right? So like, and then he like took him off to the side. He's like, "Do you know what this means? Like, do you know what reference this has or anything like that?" So understand the terms that you're using and don't just try to, throw them around thinking that, because it's a buzzword, that it's going to get you something, because someone's going to call you out on that, right? No, he wasn't hired. No, he was, yeah, you're using it. He was probably politely pushed to the side, right? It was a good laugh and probably a good first pass, but then make sure that when somebody, not everyone will call you out. A lot of people are going to be naive about things, but you are going to catch someone that really understands it, right? And same as when you go through these, projects that you're doing, don't just put something on there because you think you have to, right? Actually know what the tool is for and what its use is, or else your ignorance is going to be shown at some point, and you're not going to feel good about it. Hopefully you can brush it off and laugh at it, but again, make sure that you're intentional about your actions, and if you don't know something, that's fine, right? But just be honest about it, right? We're all here to learn. If you feel like there's something that you're not grasping, just reach out. And yep, deep learning, you can graduate. You can go on. But that's not going to be the case in business, right? Especially as you're doing these job placement workshops, and you're learning how to rebuild your resume and put different skills that you've learned on there. Do not put something on there just because you think that it'll get you hired, please, right? Because what they're going to do is they're going to ask you a question about it, right? You got neural nets on there. Now build me one. And you say, oh, what? You put big data on there. Well, get it for me, right? And if you can't, they're going to know. And you're just going to keep looking for a job and feeling bad. So please, on your resumes, you're going to learn a lot of the toolkits, right? You're going to learn sklearn. You're going to learn, you can put pandas, NumPy, matplotlib, you can put plotly, whatever packages that you're working with on there, but at least have some kind of understanding of how it works and what the different functions do in it, because they're not only going to give you their job questions, they're going to ask you about those things, right? And if you can't answer it, then you're done. And you're just going to have to keep looking. Grit, right? Man, this one, it's something that you need in every aspect of life, but definitely data science, right? Going back to that scraping thing, that one is where you'll get the most grit. I know it's not something that we really advocate for when doing the projects, because now business is moving out of that, right? There's still going to be times where you have to scrape information, but now we're working with APIs where you connect to directly to their data in some format, and you can get a lot more information out of it in a much more legible way. But grit is what's going to help you get through this program. It's what's going to really benefit you in life, right? It's just realizing that I'm going to fall, I'm going to scrape my knee, but I got to get back up or I'm done with it. And same goes with data science, right? You're going to be cleaning it, and it's not going to always work the way you want it to, right? Especially with regular expressions being complicated. You don't always know what kind of pattern I want to extract the information that I need. But even in just coding, right? You're trying to visualize something, you're getting error after error. You know, Brendan, you made the point that ours, the error code that comes out of that is just not legible and easy to interpret sometimes. And that's the case that, right, we're running into challenges and we look at it, but don't just freeze and get frustrated that you don't get it, right? Do a little more exploration, because staring at the screen is not going to solve it, right? It doesn't matter how many hours you look at it. It's not going to help you. Just try to think of, what is it that I'm trying to achieve here? What's my next step? And start looking for the information. If you really come to a wall and you feel like you can't move forward with it, right? You have us as resources, you have your colleagues, you have the internet. And that was one of the things that I was trying to say yesterday is, if you're trying to search for something, right, don't use the rambling of your brain to be your search query, right? I don't know how to fix this. What am I going to do with this question, right? Just use the keywords, right? Call out what aspect of it that's not working, and put a question after that. But all of the other language that seems to make things make sense to us, don't add that, right? Google is non-feeling, doesn't have any emotion. It wants you to be straight with it. And if you're going to get an answer out of it, and get the answer you want, not the other 800 million results that came back, you got to be intentional and straightforward with it. All right. So the last thing here, right? Peruse LinkedIn, Glassdoor, Indeed, search for healthcare data analyst, healthcare data science, and just copy them, paste them to some document, come back and we'll talk about it here in 10 minutes. I don't think we need to be in the groups for this one. We can just Google ourselves and try to come back with some of the, the preferred skills, maybe some salary ranges, maybe the additional skills that you require, whatever that other one's called. We'd like you to have this, but it's not required. Maybe a brief description of it. exercise called for? All right. We have that section on Slack. I guess we could just maybe put it in homework. I don't know if that would convolute it, but maybe just post any that you might have found interesting or found on there. We can just talk about them. Say what are some of the commonalities we saw between ones that we might have looked at. Homework's fine. Please, not all at once. I'm overwhelmed.
CDS.
CVS?
Yes.
1 year? Some programming experience with R and Python, experience in SAS or SQL? You've already got it. What else? We got Akram here going for some NLP position. Yeah, that one's going to be a little bit more involved, right? Especially all of this right here. These ones here are going to be, big data. There it's back, big data. Caret, TensorFlow, Keras. You are going to see what these ones here look like at the end of the program. We do have some education on the big data part of it, right? But we will do XGBoost. That's going to be one of the machine learning methods that we look over here. PhD, yeah, well, you're looking at language processing might be a little bit more involved. Yeah, some of them might seem that way, right? Salary is very much determined by industry, not just the position that you have. But all of those cases, some of them, right? Previous experience, strongly preferred. Doesn't mean you have to have it. But you are going to have a lot of these, right? These skill sets and tools that they want from something like this already. All right.